All right, Algebra 1. Algebra 1. This is going to be section 5.2, solving systems of equations by graphing. This would be a good section to use graph paper on, especially today. Notes, assignments, graph paper is going to make it easier and quicker for you, but that's up to you. You should put your name, date, period. Okay, you should label your notes and any assignments with what section it is. Now, what's a system of equations? So we'll get into an example here. A system of equations is just two equations or more with two unknowns. Okay, so we've solved equations before, but we've solved when there's only one variable that we had to find. But now, if there's two variables, x and y, that we've got to find, then we need two equations. If there are three variables, which is possible, you would need three different equations that relate them together. Now, the solution is some xy pair that works for both of them at the same time. And so in this first example, we're going to actually start by, I'm giving you an answer and I'm telling you to check it. So checking solutions. Okay. So a system of equations is two or more equations with two or more unknown variables. And we're going to be spending a bunch of time solving them. The first way today is graphing. And then there are a bunch of other methods too. So in this first case, though, we're going to check it. And we've checked answers before. We plug them in and see if it works, see if it gives you a true statement. In this case, it has to work for both. Just because it works for one isn't good enough. So the first thing you do is you're going to substitute the values for x and y into the right spots. And then you're going to do the work. And then if you get a true statement, that means that point works for that equation. It actually means graphically, this point is on that line. But it's got to be in both of them. So you got to check it with your other one also. Order of operations, multiplication, division before addition, subtraction. And I think I made a mistake. Oh yeah, 3 times 5 is 15. Why did I write 6? That's weird. Okay, 4 minus 15 is negative 11, so we keep making both sides. And it works, okay? So that means that 2, 5 is a solution to the system of equations, okay? And this is the work you have to show to support your answer. And I'm going to be asking you to check every answer that you find also. It's a quick thing. So example 2, how do we actually find these answers ourselves if they're not just going to be given to us? So the directions here would be like solving systems by graphing. And we're just going to stick with graphing first. This is where graph paper is going to be really helpful, unless you can draw really, really nice pictures without graph paper. It's going to take more work. So here's a system of equations. Y equals negative 2x plus 5. And y equals 4x minus 1. And so the way we solve a system of equations by graphing, the way we find that one xy pair that works for both of them at the same time is by graphing them both together on the same picture, same graph, and seeing where they cross each other, where they intersect. So let's see, this is where the graph papers are going to come in handy, but I'm going to do it freehand. You can print out graph paper online if you don't have any. Now, if I do this, I got to make a really good graph, because if you're off a little bit on these graphs, it can totally mess up your answer. Like you get the wrong answer. On graphs before, maybe your graph would just look sloppy, it wouldn't look great, but here we're actually depending on the graphs to get numbers. So these are in slope-intercept form. You usually start with, y equals mx plus b. And to graph a line, usually start with b value, 1, 2, 3, 4, 5, which is the y-intercept. The slope is rise over run. So if it's not a fraction, you can make it a fraction. Negative means we're going to go down 1, 2, and to the right 1. Down 1, 2, to the right 1. Down 1, 2, to the right 1. Down 1, 2, to the right 1. The more points you get, the easier it is to make your graph actually precise, which is going to be a big deal here. So I would crank out a bunch of points. So even if you're off a little bit with one of them, especially if you're not using graph paper, then connect them with a ruler or straight edge, put arrows on the ends. So that's one of our graphs. Then we got to do the other one. It starts at -1, up 1, 2, 3, 4, over 1. That's a good sign. It's right on top of that. 1, 2, 3, 4, over 1. You can always go backwards too. You could go down 1, 2, 3, 4, backwards 1. So if you do them both down and back, that's the same as positive slope. It should look like it's going up. And then where it intersects right here, that's your answer to the system. So what are the coordinates there? X first, over 1, up 1, 2, 3. Y value is 3. So this is our answer. Let's check it just to be sure. So I'm going to plug 3 in for Y, 1 in for X. And it works for that one. It's got to work for both. Okay. Now, by the way, in the last one, I should go back up here and show you one that doesn't work. I meant to. Let's try it in this one. These ones should always work. Like when you do it yourself, it should work unless you've made a mistake. So it works for both. So the solution is 1, 3. This is the solution. Now, jumping back up here, I wanted to show you second example. -2, 0, and y equals -2x minus 4, and y equals x plus 4. Let's try that one real quick. Try it yourself, actually. Pause the video, see if it makes sense. This is your x, this is your y. Plug 0 in for the y, -2 in for the x. -2 times -2 is positive 4. 4 minus 4 is 0. Hey, it works, but it's not enough. You got to check on the other one too. 0, -2 plus 4. It's going to be 0 equals 2, which is not equals. So -2, 0 is not a solution. You got to check them both. If you get one wrong because your work was wrong, it'll probably work in one of them. Probably because you graphed one of your lines right. So if you graph one line right and the other one wrong, your solution will be wrong for the solution, but it'll seem like it works for one of them. So let's do another one. Y equals x minus 2 and y equals -x plus 4. Let's try that one. So graph paper would be helpful here. If you can, pause the video and try it and just see if you're getting the hang of it. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm trying really hard to make these all equally spaced. If I mess this up, then where they cross it's not going to give me the right answer. So first one has a y-intercept of -2, and the slope in front's a 1. So that's 1 over 1. That's up 1 to the right 1, 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 up 1 to the right 1. The more points you get, the better your line is. You can crank them out. It should be fast. Just do a few more points. Use a straight edge. These lines have to be really good to get the right answer. So next one has a y-intercept of 4, 1, 2, 3, 4, and it has a slope of -1. If you put a number in there, that's a 1x, right? And be -1 over 1. So that should be going down, left to right, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Okay, so now we're going to connect those as nice as we can. And where they intersect, where they cross each other, this is a point. This is the xy pair that belongs to both lines, right? So it should work in both equations at the same time. It's the only point. So the x is 3, the y is 1. That should be our answer. Let's check it. Okay, I'm requiring work on your homework and classwork to get credit. You got to check it. So we're going to plug it in, and we get 1 equals 1, so that one works. And then we plug this one in, and this one works. So it works for both. So the solution is 3, 1. All right, last example. Let's see, last example. So that was example 3. So we'll do example 4. One more. And this one will have one extra little challenge to it. Solve by graphing. It's the directions. Solve by graphing. And the equations are going to look like this. 2x plus y equals 5. And 3x minus 2y equals 4. And we're going to solve by graphing. Now, what's the big difference here? This one's a little different than last. There's something different. These are not in slope-intercept form first, which is the easiest way to graph a line. So we want to change these to slope-intercept form first. These, so you want to solve for y. You got to get y by itself, right? So we're going to subtract 2x from both sides. And so we're going to get y equals negative 2x. We usually write that first, plus 5 if 5 is positive. Okay, so that one's in slope-intercept form. This one, we're going to subtract 3x from both sides. Negative 2y equals negative 3x plus 4. We're going to divide both sides by negative 2. Undo the multiplication. You got to divide everything by negative 2. Multiplication and division have to be distributed. So we get y equals, now negative 3 over negative 2 is positive 3 over 2. But then the 4 gets divided by negative 2, so that's a minus 2. So that's in slope-intercept form. So that's what we're going to graph. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this one has a y-intercept of 5 and a slope of negative 2, 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. It makes it easier if you have graph paper because you can just count the squares, and then your picture comes out nice too. But I think I'm doing a pretty good job. Might be worth it to print out some graph paper. So that's the first line. The next one has a y-intercept of negative 2. Goes up 1, 2, 3 over 1, 2. Hey, that's a good sign. Up 1, 2, 3 over 2. Hopefully, when you're graphing it, a dot from one line ends up right on top of a dot from the other line, and then that's obviously the intersection. It should be nice right now. So the coordinates at that point are 2, 1. So that should be our answer. Let's check it. Now, we check it into these. Plug y, 1 in for y, 2 in for x. 1 equals 1. And this one, plug 1 in for y, 2 in for x. The 2's reduce. You have 1 equals 3 minus 2, and 1 equals 1. So it works. 2, 1 is is the solution. Now, the one thing you got to watch out for in this problem is if you check them back into these slope-intercept forms and you have made a mistake getting into slope-intercept form, it's going to seem like it works because it's going to work for those. If you check them back in the original equations before you did anything to them, that's probably better. because the mistake you made could have been in these first steps when you change the slope-intercept form. This answer, if you graph these right, even if they're wrong, you're going to get an answer that looks like it works for both of them. So it might be better check them into the original equations. Might even be easier because those ones didn't have fractions and stuff. So I would probably actually check these in the original equations because that would be the best way to make sure you didn't make any mistakes. And it might even be easier, like I said, because they didn't really have any fractions or anything. So if you check it in the original equations, that's for sure where it's got to work. So today's classwork will be monitoring progress, starting at page 236. Problems 1 through 5 all. They're at the bottoms of the pages in the middle of the section of the book. If you're doing them online through the Student Dynamic ebook, there's little blue arrows next to each problem that you can press play, and it'll show you exactly how to do the problem. So then there's no excuse if you get stuck or just want to check your answer. Make sure you upload your notes and your monitoring progress work. Show you all your work to get full credit. Go for it.